For this chapter, we are looking at static electricity. In this chapter, there are 4 big ideas. What are they? Number 1, you need to know what are the type of charges. How do we measure these charges? What is the field that forms around these charges? And what happens when we put the charges together? Okay, so first let's start off with electrostatic. What is it? Basically, the study of electrostatic is the study of static electric charges, meaning to say the charges that are not moving. From what you learned in Sec 2, all matters are made up of atoms that contains protons, neutrons, and electrons. Protons are positively charged and electrons are negatively charged. So if I say that an atom is electrically neutral, the number of protons and electrons are equal. Electrons can be removed from an atom or they can be added, and when that happens, the atom will have a net charge. We call them an ion, and as a result it will have an electrical effect. So how do we obtain charges? Charges can be obtained through the process of rubbing. Okay, when I do rubbing, there is a transfer of negative charges, which is your electrons, from one object to another. So there are 2 types of charges, either the positive charge or the negative charge. If I place 2 objects with the same charge together, they will repel, and if they have different charges, they will attract. So question here to recap what we talked about today. What is a neutral object? Will a neutral object be attracted or repelled by a charged object? Answer is, neutral objects have equal amount of positive and negative charge. I repeat, they have equal amount of positive and negative charge. As such, they are attracted by charged object. For example, if I have a positively charged object, it will attract negative charges on the neutral object. Similarly, if I have a negatively charged object, it will attract the positively charged charges on the neutral object. So we measure charges in coulombs. The SI unit is coulombs. So for electrons, it has a charge of negative 1.6 times 10 to the power of minus 19 coulomb. And for a proton, it is positive 1.6 times 10 to the power of minus 19 coulomb. So to talk about electric field, what is an electric field? It is basically a region or a space where electric charge experiences an electric force. So looking at the diagram here, consider a single charge Q1 in vacuum. If there's another charge near Q1, the charge will either experience an attractive or repulsive force. So Q1 is here. If Q2 comes in, if it's a negative charge, it will be attracted towards Q1. If Q1 and Q2 repel each other, they are likely to be like charges. So how do we represent electric field? We represent it using field lines. Okay, electric line of force. They are actually solid lines with arrows. Okay, the arrow is important because it indicates the direction of the electric field. The line shows the path that a positive charge would take if it is free to move, meaning to say, I have a charge here, the field lines are this way, outwards. What happens is when I put in a positive charge here, it will be repelled, hence the arrow shows you how this positive charge will be repelled. Similarly, if I have a negative charge and I place a positive charge at where my arrow is pointing, it will be attracted to the negative charge, hence the arrowhead points inwards. I repeat, the line shows the path that a positive charge would take if it wants to move freely. What happens if I have a positive and negative charge? Okay, the same principle apply. You put in a positive charge. When it is nearer to the positive charge here, it will be repelled, and placed nearer to the negative charge, it will be attracted. Hence, you see the field lines points out from the positive charge into the negative charge. So if I have 2 positive charges placed next to each other, and I put a positive charge in the middle, I realize that they get repelled by both charges. Hence, this particular region here is the null region. If I have 2 bars that are charged, the field lines will point from the positive charge to the negative charge. So this is my last slide. What is the difference between A and B? Notice the fuel line, the arrow are pointing different direction. Just to recap, if I place a positive charge at where my arrow is, when it is near the positive charge, it gets repelled away, hence the arrows are pointing out. And if I place it near a negative charge, it gets attracted towards the negative charge, hence the arrows are closer. Between B and C, you realize that C has more electric field lines. The field lines are what we call denser, and this is because it has a greater negative charge. So the difference between a positive charge and negative charge is the direction of the field line, and if they are the same charges of the same type, they will differ in terms of the number of field lines depending on how much charge there is. So if there is a +1 charge, the field lines could be like B, and if I have a +3 charge, it could be somewhat like C. Okay, that would end the entire lecture for this chapter.